Good morning, everyone. I'm Kazumichi Sato and from NTT Laboratories, and he's Kota Hashimoto from NTT Communications. And Hashimoto operates DNS servers in Ocean. Ocean is an ISP in Japan. And I analyze DNS traffic data and feedback findings through the analysis to the operators. And today, we show one of the findings, DNS queries increase and the effect of DNS Prefetch. This is the outline of my talk. First, we would like to talk about DNS traffic trends of Ocean. We analyze DNS queries sent by users to DNS cache servers, and we found that total number of queries has been increasing. We then counted the number of queries sent by each user. We found that the ratio of heavy users has been increasing, and it is the cause of increase in number of queries. Here, heavy users refers a host who send a large number of queries. Then we would like to show why the ratio of heavy users has been increasing. We suspect that the DNS Prefetch function increases the number of heavy users. To validate our suspicion, we analyze DNS traffic data and web browser behavior. In this section, Kota Hashimoto talks about DNS traffic trends.
Good morning, I'm Kota Hashimoto from NTT Communications. First, I'd like to introduce DNS traffic at Ocean. Ocean is the largest ISP. Ocean is the largest ISP in Japan, and Ocean has 11 million customers. As for DNS operation, 6 billion queries are sent by users in one day. In other words, we receive 70,000 queries per second. To handle those queries, we operate 100 cache servers. This is our cache servers form structure. The DNS cache servers are behind the load balancer, and these are firewall and IDS between router and load balancer. These firewall and IDS block bogus DNS queries sent by users to cache servers. We capture DNS traffic data between router and firewall, so we can get all DNS traffic data from users to cache servers, including bogus queries. Now, I would like to talk about these DNS traffic trends of Ocean. We analyze DNS traffic data for 5 years. This figure shows change in the total number of queries and end users in one day. X-axis represents measurement date. Y-axis represents total number of queries observed at each measurement day. The date is normalized so that number in November 2006 is 1. It indicates that the total number of queries increased 5 times in 5 years. In particular, the number of queries sharply increased between 2009 and 2010. Here, we also count the number of unique end users observed each day. However, the number of end users only slightly increased during the same period. This result indicates that the cause of this increase is not due to an increase in end users, but increase of number of queries per users. This is a breakdown of this change. To determine the cause of the increase, we classify users into 5 groups based on the number of queries they sent, and observe the transition of group ratio. This figure shows the ratio of user type. X-axis represents range of number of queries sent by each user in one day, and Y-axis represents percentage of users. For example, the ratio of users who sent less than 10 queries in November 2006 is about 25%. We classified users into light users and heavy users. A light user is host who sends less than 1,000 queries to DNS cache servers per day. And a heavy user is a host who sends more than 1,000 queries per day. We found that the number of light users decreased. We also find that the number of heavy users increased. And this number sharply increased between 2009 and 2010, just as the total number of queries did in the previous slide. So we found that the cause of the query increase is the increase in heavy users.
Again, Kazumichi Sato. Now, I will talk about the cause of increase. Hashimoto mentioned that the number of heavy users sharply increased between 2009 and 2010. So, what caused this increase? We found that number of heavy users who use Firefox sharply increased between 2009 and 2010. I will show the increase later. During this period, specifically in June 2009, DNS Prefetch function was implemented in Firefox. So we suspect that the DNS Prefetch function increased the number of heavy users. The DNS Prefetch function resolves domain names included in URLs in the browsed web page in advance. This function speeds up the browsing experience, but increases the number of queries. The DNS Prefetch function is implemented on Google Chrome, Firefox, and Safari. Before showing the number of heavy users who use Firefox, I would like to introduce a method for determining Firefox users. To find Firefox users, we found hosts who resolved domain names of Firefox or its add-on server. Domain names are aus2.mozilla.org and addons.update.mozilla.org. We define such hosts as Firefox users. Note that we cannot find all Firefox users with this method, because some Firefox may not resolve such domain names during the measurement period. In addition, we might find users who do not use Firefox, because some users may resolve such domain name by hand. I would like to talk the number of heavy users who use Firefox. First, we define users who send more than 100 queries per second as heavy users. Then we selected Firefox users from heavy users. And we captured number of heavy users and Heavy Firefox users in March 2010 with February 2009. This is comparison results. Data in table are normalized so that number of heavy users in February 2009 is 100%. The results show that number of heavy users increased from 100% to 385%. and number of heavy Firefox users increased from only 4% to 65%. It indicates that number of heavy users 4 times increased in 1 year. On the other hand, number of heavy Firefox users 70 times increased the same period. So we suspect that DNS Prefetch function increased number of heavy users. From now, I would like to talk about the validations of our suspicion. To confirm our suspicion, we analyzed DNS traffic data and web browser behavior. In DNS traffic data analysis, we first selected Firefox users from all users. Then, we analyzed number of queries sent by each Firefox user. And finally, we compared the number before and after implementing Prefetch function. In web browser behavior analysis, we first browsed web page with a large number of links. Then, we captured and analyzed Prefetch queries sent by web browser. This is detail of DNS traffic data analysis. We used DNS query setter captured before and after implementing Prefetch function. Specifically, we use DNS queries captured between 23 and midnight on February 2009 and March 2010. And we counted number of queries sent by each Firefox user every second. Then we compared the number in March 2010 with February 2009. This figure shows time series of number of queries. Each line indicates the number of queries sent by Firefox users whose peak value. The maximum number of queries during the measurement period was the largest among all Firefox users. X-axis represents elapsed time from 23 to midnight, and Y-axis represents number of queries counted in each second. The results showed that maximum number of queries per second more than doubled. In February 2009, maximum number of queries was 150. And in March 2010, maximum number of queries was 350. Then we compared maximum number of queries for other users during the measurement period. Each point indicates the users, Firefox users. X-axis represents each Firefox user sorted in descending order of their maximum number of queries. Y-axis represents maximum number of queries per second. Thus, leftmost points indicate the users shown in the previous slides. This result indicates that maximum number of queries per second increased totally. From these results, we believe that DNS Prefetch function increase number of queries sent by each user. So far, we show how DNS Prefetch increase DNS query traffic and heavy users somewhat indirectly. Here, to show the relationship more directly, we observe and compare DNS query behavior of some web browsers. We first created a web page with 300 different FQDNs. Then we browse the browser page with Firefox, Google Chrome, and Safari. Finally, we captured and analyzed Prefetch queries from each browser. Here is the analysis environment, and we used Windows on Mac OS hosts. This is an example of Firefox behavior. We found the Firefox may suppress the Prefetch query rate. First, Firefox sends 3 prefetch queries and waited for a response. Then, it sends next prefetch queries as soon as a response was returned. Here, Firefox stopped sending queries when queries waiting for response amounted to 3. As a whole, Firefox resolved about 150 out of 300 FQDN. We confirmed that control implementation in the Firefox source code was the same as the observed behavior. However, it indicates that A and quad A queries were sent by an operating system's resolver. So the total number of prefetch queries amounted to 300. This is a summary of behavior of each web browser. Other browsers seem to also suppress the prefetch query rate, though the maximum number of parallel queries and maximum number of prefetch queries varies among each browser. In Firefox, the maximum number of parallel queries was 3, and the maximum number of prefetch FQDN was 150. In Google Chrome, the maximum number of parallel queries was 8, and the maximum number of prefetch FQDNs was 38. In Safari on Windows, the maximum number of parallel queries was 2, and the maximum number of prefetch FQDNs was 69. In Safari on macOS, the maximum number of parallel queries was 16, and the maximum number of prefetch FQDNs was 68. However, A and quad A queries were sent to each FQDN, so the total number of prefetch queries doubled. Prefetch query rate depends on response time of DNS caching server and number of queries per second determined by this equation. So if response time of DNS cache server is short, QPS will be large. For example, all prefetch FQDNs are in cache. So I will conclude my talk. This is summary of this talk. We analyzed DNS queries and browsers' behavior. We found that the number of heavy users using Firefox increased, and the number of queries sent by each Firefox user increased after implementing DNS Prefetch function. This indicates that the number of queries may increase by using DNS Prefetch function. We also found that browsers may suppress prefetch query rate. However, an operating system resolver sends both A and quad A queries to each prefetch FQDN. So the number of prefetch queries may double or more than double. From our results, these problems need to be considered. First, we believe that filtering heavy users may block legitimate queries sent by prefetch browsers. Queries from heavy users have increased the load of DNS servers. So far, such queries have almost all been bogus and could be filtered. However, prefetch queries are not bogus, so it may be difficult to block queries from heavy users who use prefetch browsers. Second, in addition to DNS server problems, such queries consume the session table entries of stateful firewall and large-scale NATs. Finally, if Internet Explorer implements the DNS Prefetch function, these problems may worsen. Thank you for listening. That's all.
Okay, folks, any questions?
Hi, Guillaume Leclanche, Swisscom. Did you have to change your infrastructure to support these new requests, or what was the impact on the infrastructure?
You mentioned impact to ISP or
Yeah, on the ISP infrastructure. You say it has it creates problems for the NAT and the servers. There's lots of new requests. So what did you have to build new to support it?
I did not analyze effect on load balancer or firewall yet, but in Ocean, DNS query very many queries received, and the operators present its queries. Sorry, I'm fine.
Sorry, Chris Morrow, Google. So I think his question was, did you add more servers to your set because of this increased load, or did you consider removing the NAT and firewall and doing doing local anycast load balancing or some other option? I mean, it seemed like you identified some bottlenecks, and instead of removing those bottlenecks with well-tested technology, you said, well, if more people do this, it will be bad. But yeah, it probably will be bad.
I think we hope to decrease prefetch queries by browsers.
Probably not going to decrease over time.
Hey, Sean from Mozilla. Can you just go back to slide 11? I think it was 11. I'd just like to look at the...
This right?
Yeah, that's correct. Is there a reason why you took data only for 1 hour? Is there a reason why the sample data was just an hour? Because that seems like a really small time frame for the amount of DNS queries you guys are doing.
I have more data, but analysis take many times.
So the reason I asked that is every Firefox browser that is not modified source, does not have modified source, will hit AUS2 at least once a day. So you can actually find out the number of Firefox users accurately pretty much if you look at that. So yeah, I think 1 hour seems to be really small. You have better data. Yeah. It could get us better.
Further step is needed.
Yeah. And based on your last comment, I think I agree with him. You're not going to see any of this lesson because, yeah, browsers are going to, we look at it from the perspective of user experience, and these are the things that actually speed up our, it's also called perceived performance. It makes it look that your browser is faster. So but browser vendors are always going to put in stuff like this to, speed it up. So you're not going to see it.
Thank you.
Hi, Eric Ostwell with Verisign Labs. I just wondered, I think I might have missed this. What were the big negative effects that you actually saw? Did you see performance degradation, or I think it's very interesting the breakdown you had. I just wondered what specifically bad things happened.
So I don't know. We just analyze queries. That's all.
Okay.
Thank you.
Just to echo a couple of comments there. With validation going to be happening on a number of end systems, it's quite likely that you're going to see more queries originate from the end system. So just to support that statement. Also quite curious if you studied some of any changes that might happen to the bandwidth in terms of what might have been cached data, what is effectively the change of having so many additional queries. Did you do any analysis of how much of that data being requested was already cached at your recursive name server, or what was unique?
Sorry, I want to discuss offline.
Okay, thanks.
Okay, anybody else?
All right. Thanks very much, guys. Oh, sorry. One more.
One question, Deepak from Brocade. I just wanted to confirm the number of queries you said 150. That is actually per second from a single Firefox user. Was that the number?
This one? Or single Firefox user?
So it is a single user, single PC sending 150 queries per second?
Yeah.
That's what you saw?
Yeah.
Okay, thanks.
Okay, thanks very much, guys.
Thank you very much.